Today we're going to talk about lateral and surface area. We're going to spend 2 days on this. So first of all, we have a new definition. Faces, so we're not talking about bases, are called lateral faces. Okay, kind of like a rhyme. So faces are lateral. We call them lateral faces. So when we say lateral faces, we're talking about things that are not the bases. So we're going to talk about prisms and cylinders today. We're going to do some more of this tomorrow. So let's talk about prisms first. Now, an altitude of a prism is a segment that is perpendicular. Remember, that means perpendicular to the bases with an endpoint on each base. Guess what this is? This is the height of our prism. Now, a right prism is a prism whose lateral edges are altitudes. So basically the faces are perpendicular to the bases. So this is something like a cube. An oblique prism is a prism whose faces are not perpendicular to the bases. So this is like a box that's been tilted. So here's some examples of some prisms. This one's a right prism. Well, it's written. This one's a right prism. And this one's an oblique prism. So on the right prism, the faces are perpendicular to the bases. And then on the oblique prism, this is not a right angle. Okay? So these right here, this is an altitude because it forms a right angle with, it's basically how tall it is, and this is an altitude. So that's the difference between a right prism and an oblique prism. So here are some formulas for you. The lateral area, which we use an L to represent, is the sum of all the areas of the lateral faces. So I'm going to go through and point out to you what the lateral faces are. First of all, this base is a pentagon, so this is a pentagonal prism. So if we're finding lateral area, we're adding up this face plus the back face plus this face plus this face plus this face. So we are not including the area of these bases. Okay? We don't care about those. So for the surface area, that's when we care about our bases. So let me go back to this formula. L means lateral. P is the perimeter of the base. And H is the height. So that's where you would use the altitude to determine the height. So that is your formula for lateral area of a prism. Total surface area of a prism is you add the lateral. So this is just the lateral. The lateral area, which you can find lateral area before you find surface area. And then 2 times big B. And that's the area of a base. Now the reason why we have 2 is because we got 2 bases here. So if we look back at this picture, we've got 2 bases. We got this base as a pentagon and this base as a pentagon. So let's do an example. Example 1 says, find lateral and surface area. So what we have here is we have a triangular prism. So the bases are these triangles. So that's our bases. That means that the faces, we've got 3 faces or 3 lateral faces. We've got this one. We got this one. And we have this one. So don't get confused that just because this is on the bottom, it's still a lateral face. It's not a base. Remember, the way you name prisms is based on the base. And this is a triangular prism. Okay, so let's use what we're given. First of all, let's write the formula for lateral. Lateral is equal to P times H. P times H. So the lateral, the P means the perimeter. So if this is the base right here, what is the perimeter of this base? Well, you see, if this guy right here is 20, then this one must be 20. So we can add together 16 plus 20 plus 12, and we'll get the perimeter of the base. Then we're going to multiply it by the height. Now the height is how far apart our bases are. So this is our height, is 10. So we're going to multiply that by 10. So let's do the calculations here. So if we add 16 plus 20 plus 12, we get 48. And we're going to multiply 48 by 10. So we get 480 as our lateral area. Now let's put the units on it. We have centimeters squared. So that's the lateral. Now we want to find the total. So remember, we can use the lateral to find the total. The formula for total is lateral plus 2 times the area of the bases. Okay? Now, there's something you need to remember when you're doing the area of this base. First of all, we have an area of a triangle for the base. Now, this base is a triangle, and the area of a triangle is equal to 1/2 base times height. So, total is equal to, and we already have the lateral, so I'm going to go ahead and fill that in, 480 plus 2 times, and we're going to have 1/2. The base of the triangle is going to be 12. Now notice this b is a little b, so we're talking about the base of the actual triangle base. 1/2 12 times the height of the triangle, and if 12 is the base of the triangle, the 16 has to be the height. Alright, so let's do some calculations here. That's still 480 plus, and we get 192 from this. Then we add 480 to 192, and we get 672. And the units, centimeters squared. Now, don't forget your total is always going to be bigger than your lateral, because your lateral doesn't include all of the surfaces, but your total does. Moving on, let's start talking about cylinders. So for cylinders, just like prisms, cylinders can be right or oblique. So I've got some pictures here of a right cylinder and an oblique cylinder. So this one is our right one. Because, let's see, this right here, if we drew in the diameter, forms a right angle. And this one is oblique. Notice it does not form a right angle there. We drew in the diameter. This right here is not a right angle. So you want to recall that for circles, circumference is 2 pi r. Now, circumference is the distance around the circle, if you remember, and then the area of the circle is pi r squared. So this is the area. And remember, r is the radius of the circle. Okay. So let's talk about the formulas. Sorry. So for a cylinder, the lateral area is C, which is the circumference, times the height. Now, or you can write it as 2 pi RH. Now, this is just plugging in for C. You don't have to do that. You can use either one of these formulas, but you still have to know what circumference is. Now, the surface area is, like before, we've got the total plus 2 times the base. So that's the lateral. Excuse, not the total, excuse me, the lateral plus 2 times the base. Now, the base in this case is a circle. That's why over here, when we have it rewritten, that's the area of the circle base. Okay, now let's do some examples. Now, find the lateral and surface area. Now, the lateral for a cylinder is going to be everything except for the top and the bottom. So it's like if you had a can of soup and you peeled off the label, that would be the lateral area. So first of all, let's write down our formulas. The lateral is circumference times height. And I'm going to go ahead and plug in for circumference. Circumference is 2 pi r times the height. Okay, now I picked this particular example because we're not given the radius or the height. Now what we have to do here is we have to use this triangle right here to figure out what the radius and the height is. And we've got to use some trigonometry like we did in the last unit. So whatever this is would be the height. Whatever this is would be actually the diameter. So to figure out the radius, all we'd have to do is take that value and divide it by 2. So what we have here is a right triangle. We're going to use some trigonometry. So let's go ahead and let's find the diameter first. So for the diameter, in reference to this angle, the diameter is opposite. So the D is opposite. And the 18 is the hypotenuse. Now remember we've got SOHCAHTOA. SOHCAHTOA. So if we're using opposite and hypotenuse, we're talking about sine. So sine of 30 degrees is equal to D over 18. So to solve for this, we multiply by 18 on both sides. And then make sure your calculator mode is in degree, and we're going to type in 18 times sine of 30. Now 18 times sine of 30 is 9. So that's the diameter. So what does that mean for the radius? It means that our radius is 4.5 because 9 divided by 2 is 4.5. So we're going to use this part to plug into our formulas. Now we need to find the height. Now you can use the Pythagorean theorem to find the height, and you don't even have to use trigonometry here. So I'm going to use the Pythagorean theorem to find the height. So for the height, since we have a right triangle, so we're going to use Pythagorean theorem. A squared plus b squared is equal to c squared. Remember, the c is the hypotenuse. So now remember, we're talking about this whole piece of the triangle, so we're not going to plug in 4.5, we're plugging in 9. So we have 9 squared plus b squared. I'm going to make that the height. So let's put 8 squared is equal to 18 squared. So 9 squared, 81, plus 8 squared. And then 18 squared is 324. If you subtract 81 from both sides, you get 8 squared is 243. And then lastly, take the square root, and the square root of 243 is 15.59. Now we need to use that also for the formula. Now we've got our R and our H. Now we can plug in. So the lateral is equal to 2 times pi times our R, and our R is 4.5, times our height, which is 15.59. Now, let's put this in the calculator. You can either use the pi button or 3.14. The pi button is way more accurate, so let's use that. So type that in the calculator. And we get 440.8. Let's round it to one decimal. And it's feet squared. So that's our lateral. Now let's find the total. Total is equal to the lateral plus 2 times the base. And remember for this one, it's 2 times pi r squared. You can use parentheses, you don't have to, it doesn't matter. So the total is equal to the lateral we just found to 440.8 plus 2 times pi times 4.5 squared. Make sure you use parentheses around that 4.5. So let's type that in the calculator and see what you get. And we get 568.03, so let's just leave it as 568 in our unit, feet squared. So that's the total surface area. So sometimes you're going to have to pull back some things that we've done in previous aspects of this course. You're going to have to bring in some trig. You might have to bring in Pythagorean theorem. Just be aware that you have to remember everything you've learned up to this point.